2 and 2, x2 and y2. It's going to be OX plus horizontal distance 2, because it's the one to the right, not to the left. One to the left is 1. We want the one to the right, which is 2, times cosine minus VD1, because it's still the top corner, top right corner, and since it's the top right corner, this would be 2 and 1. So now we have the top left and the top right. Now let's work on the bottom right corner. So that's to the right, so it would have to be HD2, that's the one on the right side, and it's the bottom, so we'd want to use VD2. Okay, and then let's do the bottom left-hand position, rotated about the origin on the screen. So it'll be 4 and 4, and that'll be on the left, so that'll be HD1, and still on the bottom, so it'd be VD2. Alright, so this should be correct. Yeah, it looks right to me. Okay, what it did was it rotated these points, gave us the new x1, y1 after rotation. And we'll do the same thing as we did before, where we set a temp rect to the source rect value. We've ensured that it has value by assigning the whole thing if it didn't. So the UV coordinates are done a little bit differently this time. For these UV coordinates, I've added 0.5, half a pixel, to the right from the left side of the image you're trying to sample from. That way it's not getting any semi-transparent pixels. That might not be necessary, but at some point I had some kind of problem with that, so that's why I added the half pixel. And then we get it in terms of 0 to 1 by dividing by the texture width. Now on the right hand side, we'd sample half a pixel to the left, so we're not getting part of the edge that's sort of semi-transparent. In this case though, we also have to add in the width so that we're sampling from the right side. And then we can do the same thing with the V's, be the Y, half a pixel down into the sample source, and this will be 2, surprised I didn't change that to 2 already, and half a pixel up from the sample source, and in terms of 0 to 1 by dividing by the height. Now for the scenario of having to flip the texture horizontally and vertically, let's just copy what we did before so that if anything's flagged, it'll actually flip it. Okay, and like before, we'll start adding the vertices that we've transformed, scaling first and then rotation. Everything looks good, so I kind of just went ahead and fast forwarded the process. I just copied and pasted the first one, and then I changed this to 2, 3, and 4. And then here, it'll be the upper right, lower right, and lower left. So I got the upper right texture coordinate, the lower right texture coordinate, and the lower left texture coordinate. And that concludes our basic draw method that includes origin, scale, and rotation. We'll go up to the top of the method that we just made, and we'll copy it and just paste it just above it. I'll pause it and make some changes, and I'll show you the changes I've made after. Okay, I just unpaused it. This is a copy of the other one, except that I changed this from float to an optional vector 2 for the scale. By default, we set the scale to vector of 1, 1. If the scale in here had a value, it wasn't null, then we can assign it to whatever that value was. If a scale exists where either the x or the y is not 1, then instead of just multiplying by scale, multiply by the scale.x for the width and scale.y for the height. We apply the same principle to the origin here and here. If there's no scaling, then we just assign the values the way we did before. Otherwise, as you can see, everything else in this method is the same. Then we can copy this new method, and what I'll do is I'll paste it up here. Okay, coming back from pausing it, I've made a few modifications to this one, and really all they were was to add these 3 extra colors so that you can have a different color on every vertex. And that way you can do gradient tinting across the polygon that makes up the sprite, or the polygons that make up the sprite. So this is essentially exactly the same. I've compacted some of this a little bit, as you can see here, but it is actually the same. And what I've done, the only change I've really made is to add these here. Instead of just C1, it's C2, C3, and C4. Now I'll add a couple of extra public overloads that might come in handy. If we often want to draw the entire texture map, but we don't want to have to keep specifying null, we just want to specify a position and a color, and we may want the option of flipping it, which by default is none, so you don't have to specify that. We'll just call a method we already made that will do just this. So this way, if we wanted, we could say draw entire, some position and some color, and that's all we'd need to do. We'll also make an overload for drawing to a specific depth in a common way of drawing. So it takes a source rect, a position, and a color for tinting, and a specified depth. So we can say depth is equal to z depth, which is global. As you can see, these are all using depth when we're specifying the Z value for each vertex. This way we've set the depth to a specified value. Draw a source rect, position, color. Alright, what other methods should we add? There may be some specific vertex animated effects that we might want to do. Doing something like that might be a little bit more complicated. So we'll draw single color distorted version. What we'll do is we'll make two overloads. One which will take a single color and a bunch of distortion vectors, and another one that will take a group of colors and a distortion vector. Let's start by making the simple version first. One color version of distort. And we'll just copy this line here and this line here and here. So we'll have a source rectangle, a position. We probably won't need to specify an origin very often for it, so we'll just skip that one entirely for this. And for this I'm going to make scale mandatory. Rotation. I'm sort of just showing you that there's a lot of different ways you can do this and a lot of different options you can give yourself. I'm using the options that I would most commonly use, but you may want to tailor yours to your own needs as you go. And if you find there's something you're not using very often, you can comment it out or just delete it so that you have less options to look at when IntelliSense kicks in to tell you what your options are. So this takes 4 vectors of distortion of the vertices of the sprite, so you can have it in irregular shapes, and a single color. I'm just going to pause this. Okay, so the first thing we do is we start scaling things based on scale value, which, since we made it mandatory, we don't have to actually check if it has value or not, because most of the time when I'm using this I would actually specify scale, for myself anyway. So first of all, we'll scale the width and have that be W using non-uniform scaling. Must have messed something up somewhere. Oh yeah, the source rect is not going to be optional, so instead of .value, we .width. We had to get rid of that question mark that was right here. Cannot specify null in this particular method. And we'll scale the corner relative origin. We're going to use the default, which is to use the center as the origin. We'll get the scale of offsets. So I'm going to say x01 equal to vv1 x and scale.x, and y offset 1 is going to be vv1.y times scale.y. Copy that and then just say 2, 2, 2, and 2. Copy those down to here, make this into 3, 3, 3, and 3, and then 4, 4, 4, and 4. So depending on the size of the object, if we're making it bigger, we also got to make the origin scale, and we have to scale the offsets so that they're getting bigger too. Just to save space, I'm just going to do this. What is the point after offset? So after the offset, x1 will be position of the sprite plus the x offset 1, y1 will be the position of the sprite plus the y offset 1, and that'll be my upper left. x2 will be the position of x plus the width plus the x offset 2, and y2 is equal to position of y plus y offset 2. You don't have to add height, obviously, because it's the upper right hand corner. We'll say upper right. Now x3 is like this sort of thing. x03, or the third offset, and y3 is going to be position y plus height plus y offset 3, and that'll be the lower right. So you add height, and then it'll be on the bottom. x4 will be the position of the sprite plus the x04 offset, so on the left side, and y4 is equal to position y of the sprite plus the height to get the bottom plus y offset 4, and that's lower left. Same thing with no scaling. So if there was no scaling, then we just simply need to get the values without scaling. So all I did was I copied this stuff down to here and took the extra scaling out. So the scale.x, scale.y is not in here. And since we're not adding x01 or y01, those are the x and y values after scaling. We have to change it to vv1, which is before scaling, and vv2 and vv3 and vv4. So I just copied and pasted all the stuff you need to do a rotation of the vertices at their current position. So this will rotate the vectors for x1, y1, x2, y2, x3, y3, 4, y4, same as before. Alright, and I pasted in setting up the UV coordinates again, exact same way as before. You normalize it to 0 to 1 space, or make it into a percentage, 0 to 1 percentage. And then for the flags, for flipping it, same as before. And again, adding vertices is the same sort of thing. You might be wondering why, if so much of this is the same, why I'm not calling other methods. The reason I'm not calling calling a bunch of methods is because I'm trying to maximize my performance, and I don't want to be pushing and pulling stuff off of the stack to go in and out of other methods, so I'm trying to keep that to a minimum. It's not going to hurt to have a little bit of extra code in our QuadBatch. It's all fairly easy to keep it organized and keep track of where things are and sort through it fairly quickly just using Control F and then typing in the name of what you're looking for. Okay, so if you want, make a copy of this and go up here and paste in. Okay, I paused it for a moment and went ahead and added the extra colors over here, and as you can see, it's exactly the same code, except instead of just C1 we're using C2, C3, and C4. Same idea. It would be fairly common for me to scale it uniformly, so just with a float. So one thing you can do is create another method that just calls that method, and since this probably won't be used too often, most of the time I will be using the vector2 version of scale. I'm not too worried about performance with this. So anytime you have a lot of parameters though, it can impact your performance a tiny little bit. V2, 3, 1, C2, C3, 4, and flip. Okay, let's change this to float, and we'll just change this to V1, V2, V3, V4. Good. We'll add a slightly more detailed draw. Optionally the source rect, add a position, optionally origin, and optionally scale as a non-uniform, but it should have rotation value passed in. And I want an integer version of the offsets, so let's do x1 offset, y1 offset, and so on until we get to 4. So just copy those, change this to 2, to 3, 4, and the colors, again just copying and pasting. And as usual, the option to flip horizontally or vertically, which by default is none. And as usual, let's copy this out of here and place it in here. And we're using the same sorts of variables, so we can copy and paste that too. We'll need a scale variable for the actual scale amount. By default, we'll set it to vector1. So I'll kind of fast forward through this a bit here. If our source rect is null, then we assign it to be the entire texture. And if the scale does have a value, then we reassign it from 1, 1 to whatever the value is that we passed in. If something is actually scaled, then we do like before. I'll just copy and paste the code and use the other variables. So fast forwarding a bit. Okay, so what I did was I copied and pasted from our other one, and the only thing I changed was I'm using x1 off now, or x2 off, y1 off, and so on and so forth, instead of the vv1 and all that. The only distinction is that these are integers, so we don't have to set up vectors to pass them in if we have the integers. Otherwise, it is a little bit redundant. And then the default case. Okay, so I paused it and added in the default of just setting the x1, y1 positions in that, and that's with no scaling. Okay, so I paused it again and copied in the code as before. It's exactly the same. It's just setting up your UV coordinates exactly the same way, flipping them if they need to be flipped, and then just adding them to the vertex list and calling nverts if it passed the maximum amount it's allowed so that it can restart and continue adding verts to the scene. Nverts will actually put the vertices onto the back buffer and then reset the vertex count so that we can start putting in new vertices.